I've wanted a butterfly knife since I was a kid. It's like a regular knife, but you can do cool flippy tricks with it. I probably first saw them in Team Fortress 2. Unfortunately, they're illegal in many different states and countries. There are alternatives out there, like training knives that are dull so you don't hurt yourself, or silly things like a butterfly knife comb. But I was able to get a butterfly knife recently, and it reminded me of an idea I've had for a little while. So I 3D printed this. It opens like a regular butterfly knife, but then if you press these two buttons, they're a little bit stiff. It becomes scissors. Another name for a butterfly knife is Balisong, so I call these bali-scissors. The advantage of scissors is it has two safe edges instead of just one, but you can still cut things with it. You just can't close it on your fingers like with a regular butterfly knife. Plus, I think that scissors can be more precise than knives in certain situations. This is version 2. This one's a little loose because I tried filing the holes to make them a little bigger, but maybe I got a little carried away. You can still see the proof of concept where I made the handles straight, which means that the same pins at the top can now be used to lock it closed, as well as to switch it over to scissors. This means I don't need a secondary locking mechanism in the bottom of the handle. This is version 3. It has only one button instead of two. This makes switching back and forth between scissors and balisong much faster. It's a little loose, and on this one I even tried printing a little test jig with pins and holes to try to find the right size to compensate for the printer's tolerances. My plan is to make these out of metal, and maybe even make these a real product that I could sell. But clearly these aren't quite there yet. So what I'd like to do is get back into Fusion 360 and just start over and make a fresh prototype. I'd like to make it more my own style, and I'd like to make it a little bigger. I think that most people who like to do cool tricks or collect butterfly knives seem to like a little bigger size, and I think it looks cooler anyway. I'd also like to get the tapered handle back, kinda. The straight handle, there's nothing really wrong with it, but balisongs are kind of iconic with their tapered handles, and so I kind of want to get that back. So let's start drawing something. I made the first few prototypes by physically measuring the dimensions of the knife I already had. Because I wanted to make a bigger knife, but I don't want the proportions to get too out of whack, I went to Reddit because, of course, there's a subreddit for everything, and I found a page of recommended butterfly knives. I found one of the more expensive ones and saved the picture just so I could have something as a starting point as reference. I started by drawing the blade, and I added a little bit more of an S shape to the back edge of it because I wanted to have a little bit more of a distinct style, but for scissors, unlike knives, you have to have a perfectly straight edge on the cutting side of the blade. I then started drawing the pin and slot locations for the knife. There's a central pin that I actually didn't put in the 3D printed versions. This is probably another reason why they had so much slop, but the first one works surprisingly well without it. The pins in the handle simply slide along the groove, and because there's two of them and they're concentric with where they are supposed to rotate relative to the center pin is unnecessary. But because tolerances are never perfect, the center pin probably is necessary to have actual functioning scissors. I do this next step in a little bit of a strange way that kind of bites me later. Some butterfly knives have a pin in the blade that when each handle hits it, it stops the handle from over traveling. Some butterfly knives have pins in each handle and when they hit the side of the bottom of the blade, this also stops them from over traveling. If tolerances could be made perfect and there was no such thing as friction or wear, maybe you wouldn't need stop pins and the handles could simply stop by hitting each other. You can see in this 3D printed version, I also didn't put these stop pins, and so the handles are free to wiggle back and forth and go past where they're supposed to stop at the center line of the knife, quote unquote. Between a center pin and pins in each handle, the choice became obvious as I experimented with designs. So why not a pin in the center? The first problem is that I have 2 blades instead of 1. For ease in manufacturing, I'd like these blades to be flat and simple, and I can simply just make 2 of the same part and flip one of them over. But if I wanted to do the center pin method, I would need a pin that goes only part of the way through the total sets of blade thickness, or I would need one blade to be slightly different to give clearance for a pin to pass beside it when it was in scissor mode. Another advantage of the pin in each handle method is that with a normal butterfly knife, the center pivots that each handle rotates around are also used to sandwich the handles in place. Because I have pins that need to move up and down, they can't sandwich things together and hold them at the correct width. The stop pins also function as a way to hold the sandwich together at the correct width, meaning that the pins that the handles rotate around don't have to fill that role anymore. So we end up with simple handles and simple blades, and everything works out nicely. On the knife I own, the stop pins are slightly to the left and right. This means that the handles are mirror images of each other. I also don't think it looks that nice. So I made the handles symmetric, which means I only have to make 4 of the same part. The disadvantage of this is that when the pin swings around, it has to go more into the blade itself. Hopefully this won't become a problem later, but steel is strong, and so it's more about the aesthetics of making it look good, I suppose. Here I remembered that on previous versions I rounded the tip slightly. This is a bit of an aesthetic choice, but it also is probably helpful for the whole this is safer than a butterfly knife aspect of the scissors. It also adds a little bit of strength to the tip because sharp corners are fragile and likely to chip, but that's probably not much of a real issue. The key way this mechanism actually works is based on the principle of a round peg can fit in a square hole. I decided to draw the square part on its own sketch because the original sketch was getting a little bit heavy and taking longer to load all the different dimensions relative to each other when I made a change. I also rotated the squares 45 degrees. This was done in an effort to improve the lengths of each side left when the square cuts through the slot portion of the blade. This also means that only one corner instead of 2 comes super close to the edge of the material, meaning that there's less weak points, but maybe that doesn't even matter. If a butterfly knife's handle has a taper of 5 degrees, then this means it only has to rotate 175 degrees to fully close. What this means, though, as I explained earlier, I can't use the same pin to lock it in the closed position. I still kind of want a tapered handle, though, and so I tried getting around this by just letting the blade make a full 180 degree turn, but putting a taper on both sides of the handle. For those who may not know, if you hit Shift N, it changes the colors of the components so that they're all different so you can tell them apart easier. Here's where I add an actual edge to the blade. If you look at different scissors, they can have a huge variety of different edge angles. Because scissors have a shearing action, they don't actually need to be that sharp themselves. If you look at metal shears, they're not sharp at all, they just push the metal apart. I could use Fusion's built-in chamfering tool to do this, but I want the edge to come to a stop right in the middle of the groove where the stop pin goes. There is a step in the handles to reduce the height of the button in either position. This is so that the button doesn't snag as much on things. It also reduces the total thickness of the knife. Because all of the components are linked together in one way or another, it kind of creates a strange linkage mechanism where the button has to be able to rotate without getting stuck against the handles when the scissors open and close. This affects the channel placement for some reason that I don't completely understand and is hard to explain. There's only one angle for the starting pin location relative to the center pivot where the button holes for the screws that connect to the pins end up in exactly the same place as they began when the scissors are both open and closed, where the center of the pins is concentric to the holes in the button. This angle happens to be 78.75 degrees. The pins are made up of round and square cross sections. Where the square part's located is determined by what components it needs to lock up in which state. The round bit has to have clearance so that it can slide in the groove as scissors, but it needs to lock together when it's just flipping the handles open. It doesn't really take that much to lock up two pieces of metal, and that's both a blessing and a curse. If you look at a liner lock folding knife, it really only barely touches when it locks up. So you can imagine that the way I originally designed this, where the square components extended the full length of the handle thickness or the blade thickness, that it would completely lock up the knife if I accidentally made the square component of the pin just slightly too long. And so I made it slightly too short, which gives me some safety clearance. And it's still probably locking up more than a regular folding knife. But because everything is linked, this is something I had to mess with quite a bit before I was happy with it. On my versions that use two separate buttons instead of linking them together to make one button, both pins could be the same. They're just flipped 180 degrees. But the pins have to be slightly different now if they're linked together, because they're both moving in the same direction, but different heights have to serve different functions with each pin now. I guess I was getting a little bit excited about how it was going, so I decided to mess with colors for a bit. I thought the pill-shaped button on my last prototype was kind of boring, so I started experimenting with what other shapes might work. I also tried putting a little divot for your thumb. Here I make the spacers at the back of the knife. They're pretty simple, just a 2D shape with some holes tapped in them. And I made a stop pin, but I really should have just grabbed the model from McMaster because that's what I ended up using. I wanted to use some from a knife website, but they were out of stock, and I don't know if they would have ended up being better or worse anyway. Now it's time to 3D print it. So everything was a little bit loose in general, but for some reason the screws in the bottom spacer area, only the front ones on one side were loose enough that they could fall out. Everything else screwed together fine, but just those holes on one side seemed to be a little bit too loose, which was kind of strange. I didn't notice till after I was done recording that there's some burrs in the little groove where the stop pin hits on the blade that was preventing the handles from closing all the way. And so that's why it might look a little weird in the next shot. It turned out good though. I think that it's a little bit long. I think I'd like to cut things down on both ends by like 1/2 inch, but I'm happy with it. There's still lots of things to figure out though. Like maybe you've already thought, shouldn't scissors have like finger holes or at least a spring? And what stops the button from just flopping around constantly? Shouldn't it click into place in either side? And I have ideas for all these things and more, but I'm just trying to not be a perfectionist and just get stuff out there, get a real world prototype and just try things instead of constantly going for perfection and always just being stuck in the design phase. And I'm trying to take the same approach to videos. I still have a lot to learn from a video editing and audio engineering standpoint, but trying to learn as I go, and hopefully things look and sound okay and they'll get better. And hopefully the next video is even better because I'll be using some real metal and do some machining and make an even better prototype of the Baliscissors.